yeah, make a start. I mean, I guess everyone here should have a fairly good idea about what we're here to talk about. You were all there in the summer helping us do this work. So really, as that overview, we'll give a sort of background refresher on why these workshops were important, what we were hoping to get out of them. Matt's going to give you lots of details about what we found out on the days. And finally, I will show some context of how we're using these in some modeling work. So yeah, the first and most important thing really is just to thank you all for being there. There were definitely some long days, quite a lot of trees to look over and check. So yeah, thank you to everyone for persevering in the sunshine, especially people who were there on some quite wet days, and those who waited out the storm at Hatchlands to make a start. At least the day ended up fairly sunny in the end. So, like I say, the background to the work. We have this growing problem. There's an increasing number of various pests and diseases, species of insect, species of fungus, and bacteria that haven't been present in GB that are now arriving. And this is a trend globally. So there's a graph here showing records from North America, from Europe, and from the UK and everywhere, yeah, throughout the last century, but really, especially throughout the last 50 or so years, really increasing number of arrivals. I guess increased trade is the number one thing that's fostering this. We're bringing things from all over. So we have things that we're worried about arriving. This is the emerald ash borer. So this is a beetle. It's very similar to the Agrilus we were looking for on oak trees. It's called Agrilus planipennis. It's from China, but it's caused massive problems in North America and is present in Moscow and Ukraine. So this is something we're very worried about arriving, but is not here yet. There's also ash dieback, which is something that's here and causing lots and lots of problems. So yeah, really a growing problem of new species arriving into the country. It's not just new arrivals and transport links that are causing these changes. We've got a changing climate. So here we've got the example of acute oak decline that we should all have looked at in the summer. And yeah, this is involves a beetle that's very thermophilic. So it likes warm areas. As the south of the UK gets warmer, it is doing really well. The beetle, once described as a rare native, just found in parklands, is now being found all over in quite large numbers. So we've done some risk maps from reports that we receive in through Tree Alert, and found these are linked to warmest areas of the country, areas with low rainfall, and interestingly, areas with high nitrogen deposition and low elevation. So something in the climate is allowing this once rare beetle to do quite well. As a quick refresher to everyone, these are some of the symptoms that we've been looking for this summer. These stem bleeds, this dark liquid running out of cracks in the bark, can be either individual points or quite frequently on the stems of trees, and these hard to spot, very small Agrilus bigotatus emergence holes. So in both these cases, public involvement is really, really important. If we're wanting to find new things that are arriving before they cause large-scale problems, early detection really helps. If we can spot it quickly, potentially eradicate them, and yeah, it gives us a really good chance of control if we can find new species shortly after they arrive. But also in the case of AOD, sort of delimitation, understanding where things are in the country helps us plan for risk, helps us plan potential management interventions, where it's a good idea to plant tree species, etc. So all the reports we receive are really, really important, especially natural environments. It's quite a large area, not visited by many people. So trying to survey this is difficult. So just pure numbers, eyes on the ground, spotting the needle in a haystack. Yeah, without public involvement, we're going to really struggle. So we have a couple of programs Forest Research runs, Observatory, where there's a lot of time put into training specialist volunteers, so a group of about 200 people. And also Tree Alert, which is something we're trying to raise awareness of in the summer as well. There's a web page, I'll put the link here again. If you see any your concern a tree, you can report it through Tree Alert, and there's a group of experts, diagnosticians, who will help you figure out whether this is something to worry about, what it may be, and point you in the best direction of advice. So that's background. Now I want to talk about the aims of the workshops we've done this summer. And really, it's all about trying to add value to these reports that we're receiving. If we know a little bit more about the accuracy of reporting, we can better understand things like the prevalence of diseases, how many trees are affected, the distribution of diseases, where we should be looking, as well as things like pest freedom that's important for international regulation. How likely are we to have none of the pests present? So how certain can we be that emerald ash borer isn't in Great Britain already? If we can show the value, we can make the case for more training and support for these volunteer programs and landowner programs. So key thing to understand is these visual inspections are a diagnostic test similar to, I guess COVID tests would be the obvious one that's in everyone's mind still. We need to know the accuracy. How likely are we to find something when it's there if we apply this test? And that's called sensitivity. We also look at specificity. So how likely are we to correctly say something's not there when it's absent? And if we understand these two metrics, we can do quite a lot more with all the data that arrives in. So here again, a refresher: sensitivity and specificity, really important. How likely are we to spot things when they're actually there? How likely are we to make a false negative report? We can calculate some important metrics. So we can say pretty quickly what the prevalence is when we detect it. If we know where we're finding things, what the sensitivity is, how often we're looking, we can make good estimates of prevalence. We can also, as I said, make estimates. How confident are we that something's not here yet? And that's really important for international trade and reporting. We can also do things like try and optimize our surveillance location, so we can pick the best places to look to find things as early as possible. So here, just one example, using insect traps to look for emerald ash borer, to show the kinds of things we can do. I'll then come back at the end of this presentation and show how we can link in volunteer reporting to this type of process. Really, the questions we're asking here are: how many traps should we use and where should we put them? So we can see graphs in the lower left-hand corner. We've got a number of traps along the bottom axis. As it goes along, each new trap you add, you get a little bit more likely to detect emerald ash borer. But we can see this isn't a linear relationship. So early on, adding traps really makes a big contribution. Later on, the additional benefit of each trap is smaller. So there's a cost-benefit trade-off there, and we can start to figure out what the best number is to look within various budgets. We can also look at where we should put traps in the country, and we can do this through models. for these, sensitivity is really important. So we can see we've got two things mentioned here. Girdle trees, really, really effective, high sensitivity, and these coloured sticky traps that are fairly effective, but much less so than the girdle trees. So the sensitivity affects how we place the different surveillance measures through the country. If you can be fairly certain that you're finding things all the time, you can really spread out your effort and look widely across the country. If you have some uncertainty in your trapping process, then you want to put lots of effort into the high risk areas. And so we think similar things might apply with training. Where is it best to recruit people? Where is it best to direct people to look for pests and diseases? Now hand over to Matt, who will take you into some of the details of the workshops we ran this summer.
Yeah, right. Well, first of all, I'll just double check that I've now got control. There we go. My mouse moving around on the screen, so that's all good. Yeah, so that was a nice introduction of the background there, like the problems we're facing, the and understanding the importance of quantifying the diagnostic sensitivity, so the probability of seeing something when it is there, and the specificity, the probability of correctly identifying something when it's not there. Obviously, like Nathan outlined, the use for those, because you don't want lots of false positives or false negatives. So you're either going to miss lots of things or report lots of false things. And as Nathan outlines, visual detection is really important in plant health, because before something is tested in the laboratory, for example, it needs to be identified as potentially diseased first. So it really it underpins plant health surveillance still. But yeah, unlike lab tests, we don't quantify the sensitivity and specificity of these visual tests, which we need to do. We need to know for example, for the modelling that Nathan was showing with emerald ash borer. So then, specifically the objectives from these studies. So I should say we're going to cover two. It all falls under the same project, but we did two different parts of the work. So first, this is going to go over the bit of the study we did during 22-23, which really outlines the rationale and why we did what we did in the surveys this year, and helps to really put all the findings into context. So our initial objectives were, to actually understand whether surveyors differ in sensitivity and specificity with visual detection. Because prior to this, we just didn't know the figures in tree health and wider plant health in general. It's just been a neglected statistic. Then moving on to the next one, if it works for me, it's a bit of a lag. There we go. Is obviously, if we're surveying different symptoms, how much does this differ? So first of all, whether people differ, and secondly, how these symptoms differ, all important, obviously, parts of planning surveillance strategies, because obviously pests and diseases present different symptoms. And then third was actually then to look if we could quantify those two parameter values in the absence of a gold standard. So where's our gold standard here? So it's basically a reference set to compare them against, so what's diseased and what's not diseased. So in our cases, we all went around, did the survey, and then Nathan went around and assessed these trees afterwards as well. And having looked at the trees for over 10 years, really, it's a bit of a unique case, and we're assuming this is about as close as we can get really to a gold standard to quantifying sensitivity and specificity of people. But obviously we need to actually roll this out on a wider scale. We need a method to do this, without this gold standard expert validation data set. So if I then go on to the next slide, if it comes on for me. Sorry, it's a bit of a lag here. Nathan, you able to click me onto the next slide?
This one, I'll move you on.
There we go. Yeah, I think that's easiest because there's definitely a lag on my part here. So if you can move me on to the next slide. Yes, obviously, as we know, you know, I think you'll all be familiar with these symptoms now of acute oat decline. So it was a nice case study to do. Obviously, because as Nathan's outlined, the problem that we have with acute oat decline and the use of public reporting and landowner reporting of the visual symptoms to build up these acute oat decline distribution maps to better understand what's actually going on. So it's valuable from that perspective, but also, as I said, I've got Nathan, who's effectively the gold standard test here, and also it presents a few different symptoms. So on the left, obviously, you can see the stem bleeds, which you'll be familiar with by now. The center, there's some cracking there in bark plates, which we didn't look for this year because, as I'll get onto, is just a bit of a random symptom to detect. As you can imagine, trying to detect, extensive bark cracking from fishing is quite difficult. And then obviously those small little tiny Agrillus beetle exit holes that were, a pain and difficult to see. So we have a variety of different, well, not just symptoms, but signs with different sort of different difficulty levels, if you like. So you can imagine the beat. Well, we know that the exit hole is really difficult to see, and the bleeds are obviously comparably easier to see. So it's a nice case study to use. So there we go. So then, similar to what we did this year, but we did it at 2 sites, Hatchlands and Richmond. And this was surveying a larger number of trees, looking at it was 175 trees across the 2 sites to then get this initial idea of how the sensitivity and specificity vary between symptoms and how they vary between individuals. And like we said before, not as a test, there's no right or wrong answer, but it's basically, as Nathan highlighted with the Emerald-Ash-Borer map, just so we can quantify and then use in surveillance. So here's what we found. So as you can see, the sensitivity there on the top graph, so the likelihood of the probability of correctly identifying a symptom when it's there, you can see that differ between the symptoms, and you can see that the stem bleeds have the highest sensitivity. So when the stem bleeds are there, they're most likely to be picked up. And we can also see this obviously differs between individuals. And interesting there, if we move on to the specificity where the trees didn't have the symptoms, we can see that obviously, it was more likely that people had correctly identified negatives than positives, which is obviously good news. So it means that, in terms of laboratories, for example, false reporting will be limited. And we can also see, this varied again between symptoms and surveyors. So then when we plotted this up with the true positive to the false positive rate, it really enables us to look at the value of the different symptoms with, if it's along the dotted line, that is random chance, basically. So it's 50-50, false positive to true positive. And, you can see that basically the stem bleeds were the most valuable symptom. And as you can see here that, everybody had a above the random chance. So it was a very useful symptom to detect for everyone. So it had the higher true positive rate and a lower false positive rate. And then if we click on to the next point, there's a bit of a lag on my computer here. There we go. So we can see that, exit holes also fall above that dotted line because although they're really difficult to detect, as we all know from doing the surveys, it's uncommon to falsely report one of those exit holes. But then, as you can see, the bark cracks are falling much closer to that dotted line. So, for a lot of people, it was no better really than the random chance, which is why when we did the surveys this year, we didn't do the bark cracks, but we looked at the 2 symptoms that, were the most, that had value in everyone surveying, basically. And also, yeah, as we know from the survey, recording these different symptoms, it takes quite a bit of mental energy. So looking for 2 symptoms versus 3, it's much easier to do. So then if I move on to the next slide, I think, yeah, if you're able to do yeah, there we go. So yeah, there we go. As outlined there, you can see that the agrillus emergent holes, yeah, smaller than you might imagine. Yeah, absolutely tiny. And you can understand why, they're obviously very easy to miss, So yeah, it was around that 0.4 mark of probability of actually seeing when it's there. And for bleeds, yeah, it was obviously higher than that. So then if we get on to the next slide, there we go. Oh, it's actually worked this time. So then obviously the next objective, we can see that this sensitivity and specificity varied, by symptoms, and this really, and we can see that it varied between people as well. And highlights the need to quantify those parameters really on a larger scale for visual detection. So as I highlighted, then we looked at different methods of how we could do this without having a gold standard, without having anything effectively to compare the results against. So we looked at this through basically through simulation studies. I should say the paper will be available online soon. So yeah, we looked at this through simulation studies, and basically, there's a method that you can do this using basically Bayesian inference, so probability statistics really. And effectively, what you need is you need a high true disease prevalence area and a low true disease prevalence area. And then what happens is then if you get individuals to then assess 80 trees in a high true disease prevalence area and a low true disease prevalence area for 2 different symptoms, so say stem bleeds and exit holes, then you can effectively, sorry, it's delayed again. If you're able to click on to the next point for me, if that's okay. There we go. So basically, then you can, record the presence or absence of those 2 symptoms, and then you can express that really as a probability of detection outcome given plant infection status, i.e., sensitivity and specificity, and then you effectively compare from these high and low true disease prevalent sites, which is the information you need. Obviously, need some information to drive a model, and idea of where is a high true disease prevalence area and a low true disease prevalence area is enough to drive the model and give you an idea of the sensitivity and specificity of individuals. And we can assume where we might know a high and low disease prevalence area is from when we have delimitation surveys where, somewhere is first identified closer to the sense, you're obviously going to get a higher prevalence. And further out you go, you get lower prevalences. So just visualizing some of the output here. If it comes up, basically, you can put in different knowledge of your sensitivity and specificity beforehand. But as you can see here, so the red lines represent the red crosses on the bottom represent the simulated surveyor data, and the purple density plots. That represents probability density, our confidence really of those parameters, the sensitivity and specificity. And the bottom line to take away from this is, like I said, you just need an idea of where's a high prevalence site and a low prevalence site to then drive the quantification of the sensitivity and specificity parameters to understand these distributions. So if we move on again, Nathan. There we go. So then basically obviously from that initial study, then it gave the motivation for this year's project, continuation. And as you've seen from there, there's variation between individuals. And, we wanted to see how we could explain this to some degree, to what degree was it influenced by different levels of experience or different levels of training, And like we emphasised during the surveys, and you can probably see better now, it wasn't designed as a test, but just so we can quantify differences to then so we can put them into surveillance models. Um, and then also, we wanted a better understanding of participation in tree health events and how we can improve, which is why I'm very grateful, for everyone completing the post-survey questionnaire, so we can improve in future. Because obviously, as the third point mentions here, the importance of raising awareness of tree pests and diseases, because obviously, public reporting and landowner reporting is essential. So here we're looking to basically better quantify those differences in detection and increase awareness of tree health knowledge. So then if we move on to the next slide, Nathan. Brilliant. So then if we recap what we did, so obviously we had 4 different survey sites across 8 dates, which was fantastic coverage and great attendance. So then each of these sites, Nathan, the survey is long term. So, again, as close to a gold standard as we can get. So he knows the trees, as well as anyone can know them really, and where they have symptoms and don't, from repeated surveys. So then obviously on these sites, as you remember, we all had our introduction to acute oak decline, and we went through the booklet and the guidebook. And then on the survey days themselves, then, because as I said, we wanted to look at different impacts of training and awareness campaigns. So, so some of us, Nathan, showed symptoms physically before the survey. And then others, we went off the guidebook, so we could understand the difference between having, in-person training event versus having a mass awareness campaign, say from a guidebook or photos. And then obviously, that's why at the end we offered to go through the symptoms or uncertainties with everyone, just to make sure we all left, with a degree of confidence and similar training levels on the disease. But then obviously after those training, then we went out and did the survey. And again, thanking everyone for the massive effort there, because we know that recording 80 trees, it's hard work. So like I said, that's why we cut down from the 3 symptoms to the 2 as well, to try and make it as least work as possible. And some beautiful working locations as well. So if we go on to the next slide, Nathan. First of all, I'd like to say, amazing response to the event days. Completing the surveys, like participating, we had 164 individuals, which was, really amazing sign up. And again, a really amazing number of completed pre-survey questionnaires. And I'll mention, I said that, we're still collecting a few responses from the post-survey questionnaires, so we'll go through those shortly. But this just emphasises really, the great mass participation we had. We collected a lot of assessments for the stem bleeds, as you can see there, and we also collected a lot of assessments for the exit holes. It was an amazing participation and amazing data set to work with there as well. So if we go on to the next slide. As well, as I said, one of the objectives, it was great because, gave the opportunity to reach out and, to engage lots of new individuals, lots of you guys with tree health. We could see that, around 50%, 59% hadn't previously received disease training, or around the same for conducting, a disease survey as well. And we could see, compared to confidence with identifying tree species, we could see a less confidence in ability to recognize pests, tree pests. So it was, that was an objective that was fantastic to be able to undertake, to try and spread as much awareness as possible, and then also have the pleasure in running these events and spreading this knowledge, so we can all help take care of the trees. And then if we go to the next slide, then specifically for oak as well, which obviously a lot of people have concern for, and particularly you know, in the events, speaking to you guys, you know, you say you might have concerns for local oak trees around. So, you know, as we can see here, the specific benefit then for doing this for acute oak decline, and obviously, you know, oak has a special, you know, a special place among British trees. Really, it's you know, it's what you imagine in a classical British landscape. So again, it was great to be able to spread this awareness specifically for acute oak decline and contribute to that. So then if we go to the next slide, and this is really looking at the survey data. So, so yeah, first of all, first step was obviously then to visualize some of the findings that we have. So, you know, this is sensitivity and specificity. Sorry, this is just a sensitivity. And clearly, as you're probably not surprised by, you know, we can see that the stem bleeds were, when they were there, they were much much simpler to detect than those tiny little exit holes. And we can also see there, as I point out at the bottom, this is just visualizing. So it is, I'll show you the statistics afterwards. We can see that training appears to reduce that variation between the sensitivity and increase the sensitivity slightly. So if we go to the next slide, just a different way to visualize that. So you can see the different distributions there, you know, between the exit holes, you know, bringing that distribution, sort of making it sort of narrower for the trained individuals, and also increasing the sensitivity slightly. So then if we click onto the next slide again, and then for specificity, so when things weren't there, that's really great news, is that we can see, you know, there's no sort of evident effect there. So, you know, when something isn't there, it's, you know, there's no effect between training groups, or if people have conducted a tree health survey before, there's no evident effect on whether, you know, that increases like false positive reports. So, you know, if something isn't there, people basically, you can see it's a very high figure, you know, we're unlikely to falsely report something. So that's really great. One, in terms of laboratory diagnostics, in terms of, you know, not overwhelming laboratories with false reports. But then secondly, as I highlighted, that probability statistic calculator for these parameters, the more idea you have of, or more knowledge you have of some of the parameters, the better information you can get from it. And obviously here we can see that, you know, the specificity is typically always pretty high. So that, again, that highlights the value of having, you know, public reporting and and, you know, so yeah, everyone did a great job. So if we go to the next slide, and that's just another way to visualize that, really, you can see the level of specificity there. And then if we click on to the modeling, so yeah, basically based on that visualization, see that there was, you know, some effect of training group, whether Nathan showed people the symptoms in person before doing the survey, or going from the guidebook. And really the idea was, one, to see if there was a difference there, and two, to actually be able to quantify it. So then, you know, with that ability to quantify it, then we can input that into modeling, which Nathan ran over. So yeah, basically unnecessary detail there, but basically we built different models and then ranked them based on information criteria. And then if we look at the output, the next slide, you know, we can see that the modeling supports the strong impact of the number of, so actually, I didn't mention this before, but obviously, you know, if you have more bleeds or more symptoms on a host, you are more likely to detect it. So that effect is really strong and really clear. But where effects become more evident between people with different training and different experience is when, you know, we have a really low number of symptoms. Like you can see here, there's quite a difference between those that have training and have previous disease survey experience between those that don't. So again, it's not saying anyone scored badly, or there's no value in this or that, but it's saying those that were trained and had survey experience, you know, scored much higher with sensitivity, particularly at the low levels of symptoms. And if we go to the next slide, and again, similar for the exit holes, really. Then. So again, it allowed us to quantify these differences. And as perhaps not so surprising, it's such a low probability of detection when we have a few exit holes on a tree. But as a highlight, because it's unlikely to falsely report exit holes, it's a very useful symptom to assess. So if we go to the next slide. So I'll just summarize quickly before handing over to Nathan. And basically, it's able, and this survey this year has been invaluable. It's enabled us to it's something unique, getting such a large group of people together with different levels of experience with trees and tree health and conducting this survey to then be able to allow us to then examine different training methods and quantify these differences in symptom detection. Like I said, not as a test, but so we can use it in modeling. And like I have mentioned, it's directly applicable, which is what Nathan's just going to go over next, to other pests and diseases, not just oak. So we have bleeds are a common symptom for, say, Phytophthora, and then the exit holes are obviously a relatable symptom to emerald ash borer. And that's not to, and then obviously, like I said, we have this general method for quantifying the sensitivity of individuals. So it's widely applicable to plant health on a larger scale, not just oak. So I really wanted to get that across. And it's been great to engage so many new individuals. And I'll rush through that because I'm aware that it's 22, and we have Nathan's going to outline the bigger picture of the importance of what we've done and where we can go next. So if I hand back over to Nathan.
Brilliant, thank you, Matt. Yes, I'll move through this last summary fairly quickly, but I think useful for people to see what we're doing with all this data. So as I mentioned, emerald ash borer is an important case study, something we're very worried about arriving here. It's not here yet, but we can still look at how best to prepare for it arriving before it gets here. So we had a big project led by Rothamsted Research called Smarties, and we built a model that had a quite detailed ash landscape, and then lots of parameters describing the beetle life cycle and how it spread around the country. So small local flights and then larger movements with firewood. We linked that in with lots of Forestry Commission information on firewood arrivals for likely entry points. So we had a pretty good model that told us if it's arriving in certain places after each year, how many infected trees there are in each 1 kilometre square across Great Britain. And so we could then, as I showed previously, look at various different trap deployments. What is the best way to catch this thing quickly? So we've also extended this work now to include volunteers, and we focused in on observatory because there's quite a lot of information available there. So we could look at how far volunteers travelled from home and start to make dispersal kernels, and that really just allowed us to generate lots of random locations where people may have gone to look, and potentially, now that we know the sensitivity, how likely they are to find EAB if it were there from our model outputs. And so just one very quick slide to summarize this. Obviously, over time, it gets more and more likely to detect things. Here we've included a red line, which is official survey just at the 50 high-risk ports and depots, and that picked up about 34% of arrivals detected. Still quite a lot of room to play for. These 150 or so active observatory volunteers, we're finding around an extra 7%, so that's a 20% improvement just from this small cohort of well-trained volunteers. So it can really show it's quite a big impact that observatory is having, especially when we consider that this is one of the many things they could go out and find. So this really makes the case for observatory being worthwhile. We could also run models and look at what if we had a larger number of volunteers, and again, it just grows linearly with number of volunteers. There's no sign of a plateau, so there's a strong case for putting in the support to have a larger group of trained volunteers. So that's really useful at a policy point. Move on to the bigger picture. So these are things we may want to look at in the future, things we've taken from what we've found already. So just understanding these variations in sensitivity really help with these optimized sampling strategies, and it really lets us pull in these volunteer or landowner reports in line with official surveys, so we can really make best use of all that information, which again makes a really strong case for providing more training and more information. It's really, really useful. So as a future research question, yeah, just looking a bit more in how people look when they go onto site, how many trees they may be checking. Here we set out a fairly rigid course of 80 trees and ask people to check the individual trees, but we don't know if that reflects what people would actually do when they're walking around a wood. How many trees would you stop and look at in detail? So there's an important future research question there. We feel we've quantified the benefit of in-person training. So this is something Observatory does. For these 200 people or so who are signed up, there's lots of in-person training and a real strong focus. And we've shown that with that kind of in-person training, people are performing better. We've got some future research questions as well. How do we do this to a larger audience? Are there other alternative types of training, online interactive training, or working with groups to cascade information through wider networks? We've communicated with lots of individuals that either attended or didn't attend pest and disease surveys previously. Hopefully we've raised awareness of oak, but also of the wider use of Tree Alert for problems on that you may come across on your trees or trees you're passing. So hopefully there's a ripple effect of knowledge and moving us towards a more biosecure society. Really, yeah, we just hope all of this work helps increase the number of eyes on the ground, the provision and support for people who are interested to go out and look. And finally, just a thank you again to everyone who came along and joined us on the day.
Yes, great. And yeah, I'd also like to say thanks to the probability calculator. Also had collaborator from Robin Thompson from University of Oxford, and Alexander Maston also worked on that as well. So yeah, that was great. So I'll stop the recording now, and then we can go over if anyone has any questions.